guys, so today we're going to do an introduction to complex numbers and how to simplify them. Complex numbers have a fascinating history. So I'm going to put a little video on a short video on the history of complex numbers in here as well, and I highly recommend that you take a look at it because they are just absolutely fascinating. So let's get started. So complex numbers, what are they? Well, they can also be called imaginary numbers or lateral numbers. And you guys are probably really familiar with the terms complex numbers and imaginary numbers, but they are neither complex nor imaginary, okay? Complex numbers are really not that hard to understand, and they're certainly real. So using the terms complex and imaginary to refer to them is really sort of deceiving. And actually, those terms were kind of meant as slights to these numbers, because when they first came about in history and were discovered, they were really taboo. People did not want to include them as numbers. They were like this big, almost like cultural shockwave to the mathematical world. So that's why they got these names, because it was actually almost a way to make fun of mathematicians who are using them. Oh, you're using those imaginary numbers that don't really exist. But they really do exist. They are very much so real. So lateral numbers is a much better descriptor for these numbers because they're numbers that run laterally, almost like they have this dimension to them that runs laterally. So you'll hear me refer to them primarily as lateral numbers, and that term is gaining a little bit more traction and is trying to become more popularized in the math world. And when you watch that history video that I give you on complex numbers, which is incredibly interesting, and I highly recommend it, you'll sort of see why they got these terms, complex and imaginary. So what is a complex number? A complex number is a number that consists of a real part and an imaginary part. So you can write them in the form of a plus bi, where a is the real part and bi is the imaginary part. And this I, so where I is equal to the square root of -1. And which implies that I squared equals -1, right? Because if we square both sides, we get I squared equals -1. So we're going to be using this a lot in our simplification and in our math of complex numbers. We're going to be using these constantly to simplify and to perform operations on lateral numbers. Here are a few examples. So 3 plus 2i. In this example, 3 is the real part and 2i is the imaginary part, and then 4 minus 7i. And in this example, 4 is the real part and -7i is the imaginary part. So let's take a look at how we simplify these numbers. So up in the corner, I've put that definition because we are going to be using it and referring to it. Here's our first example. It says simplify the square root of -4. And whenever you're simplifying these guys, you're going to use the same trick. So we know that with radicals, multiplication of radicals, right? Multiplication is like the best operation for anything. It allows us to do a lot of really useful tricks. So when we have multiplication of radicals, we can separate factors underneath the radical. So if we have the square root of -4, well, that's the same thing as the square root of -1 times 4. So when you're working with simplifying, you're always going to pull a -1 out. And that's because we have this lovely definition right here. So then, again, multiplication of radicals allows us to separate these. So that's the same thing as the square root of -1 times the square root of 4. Well, we know what the square root of -1 is, you guys. That's I, right? By definition. I is equal to the square root of -1. And we know the square root of 4. The square root of 4 is 2. So my square root of 4 is going to become 2, and my square root of -1 is going to become I. And you always want to write the I to the right of the number. So this simplifies to 2i, right? Because the square root of -1 simplifies to I, and the square root of 4 simplifies to 2. Okay? So you're always going to do the same trick. You're going to pull a -1 out of whatever you start with. If you have a negative under the radical, pull a -1 out like we did here, break them apart like we did here, and then simplify. Let's take a look at one more example. So simplify the square root of -60. So again, I'm going to do my first trick where I separate this I always pull out a -1. That's always the first thing I do. So -60 is the same thing as -1 times 60. And now I'm going to separate my radicals because I can. But The rules of radicals allow me to do that. So this is the same thing as the square root of -1 times the square root of 60. Well, I know what the square root of -1 is, right? This first piece, that's I. And I know how to simplify this. I know how to simplify the square root of 60. So I'm going to take 60 and I'm going to do my prime factorization. So we have 12 times 5. 5 is prime, 12 is not, so I need to keep going. 4 times 3. 3 is prime, 4 is not, so 2 times 2. Okay, now it is completely prime. And since this is a square root, that means my index is 2, so I'm looking up for pairs of numbers that I can pull out. And I'm going to go pretty quickly through this because hopefully at this point you guys remember what to do. So that means my 2 are going to pull out my pair of 2's to 1, 2 on the outside of the radical, but my 3 and my 5 have to stay inside the radical. So this square root of 60 simplifies to 2 square roots of 15. Okay, so now I have both my pieces, I and 2 square roots of 15, which means that this simplifies to 2i square roots of 15. And remember, whenever you have a radical in your answer, it always is the last piece. It always goes all the way to the right, so you don't accidentally put like the I or the 2 underneath the radical. So my I is going to go to the right of my number, and if I'm dealing with a radical in my answer, it always goes all the way to the far right. So that's it. When you're simplifying with negatives underneath the radical, use that trick. Pull out a -1, okay, as a factor, because you know what the square root of -1 is. It's I. So the square root of -1 will always simplify to I. Okay, so that makes it really easy. And then the rest, you know how to simplify numbers underneath the radical already. Okay, so that's it. So now let's take a look at how we perform operations on complex numbers, lateral numbers, I should say. So here's 2 examples for you guys to try on your own. Hopefully you find this pretty easy. Use that trick. Factor out a -1 underneath the radical because we know what the square root of -1 is. It's I, okay? And now the great part is we know how to deal with negatives underneath the radical. Before we just said, oh, not a real number. Well, now we know what to do, which is awesome. And I hope you enjoy working with these really incredibly amazing numbers. Imaginary numbers are so useful. We use them all the time in electronics, electromagnetism. So I hope you enjoy knowing a little bit more about them. Let me know if you have any questions, and good luck and have fun.